Good noon, everyone. Let's start the session number 2 for today. So there was a query. Query was that while working on SPSS, if some of the statement is cross-loading, for example, satisfaction 2 was a cross-loading. So there we can, how can we remove it? Let's just check it whether it's a cross-loading. Yeah, satisfaction 2, there is a cross-loading in more than one variable. Now, in this case, what we'll do, we run the factor analysis once again, and we remove the satisfaction 2 from here. We remove it and then run it once again. And then just see rest of the cross-loadings, you can work accordingly. How to work on the same in the RStudio? Can you make any guess? What we'll do? So basically, here in the demo file, we need to make a change. We need to make a change here in this file. So there are a number of ways I can extract it. Like remember, there is a -1 also. So I can use the other formulas for capital bracket, or I can simply say 10 to 30, or I may take it like this. Then in that case, I have to use this C, 10 to, let's say 21, comma, 22 to 30, 23 to 30. So that particular thing will be omitted out. Okay, bracket is missed. Okay, so it means that 21 statement will not be taken. So I will take only those, or there is another method of using the minus symbol. These are some elementary knowledge about the R. So we can remove it from here and then we can rerun the process. Now rerunning the process, it's so fast. Let me show you its real power of the R. Like this is the case, R and all this. Let me just tell you about this sync also. I know this sync will be just like the same. First thing, yeah, recording is started. This sync actually may create the same sort of a problem which nomological validity study resulted in. Number of people, they make incorrect use of the sync and then create a lot of problem to themselves. The sync is, it simply says, when you write the sync command, basically we are instructing R not to write anything on the console and put it to somewhere else. So I must give a name, like as of now, see in my folder, is there any file called Z? I can see the file, doc file of the name Z. No, I don't have. I say sync z.doc append is equal to true. Meaning of append is if I do successive operation, it will keep putting there. It won't replace the earlier content. So let me start the sync. Sync is done. And now what are the things I want in my file? I want, don't want the summary. I want KMO done. So you won't see the result here. It's going in that file. Core test result should be there. Eigenvalue, I may get eigenvalue, that is. Then print of this command I want. Alpha also I want. Then factor scores, I don't remember, need. And then close the sync. Now, shall we see the output? It's all is done. Is there any file Z? Just check it out. So this is the power of the R. You know, initially it may seem like how will do, there are so many commands, etc. But the real power is you just write the code once, make slight changes, select all, press enter, and done. Everything that goes into the Word format. By the time you will open the other software, see MS Word is taking so much time in opening up. So this is KMO value, then there is the MSA value, all the values are here. This is the loading matrix, etc. These are those things, these are the liability statistics, these are the other things. So all the things will come here. So sync is basically a sort of a bypass to the console. So not to the graph. Remember, the graphical things doesn't come here. You must close the sync. If you don't close the sync, what will happen? You are doing something else and that is also going there. Let me check. If I'll run R, yeah, it's available in this. That means my sync is closed. What people do directly, that they start the sync, they don't close the sync. If you have noticed one thing, the sequence of the file does not matter in R. Sequence of the command. I run first sync and then I run only those which I want to be there in the doc file, and then I close the sync. Again back to the console. It comes back to the console. I have explained this example of sync. If it's not clear to you, I have explained it on the YouTube in a separate video. You can just refer to that video. So if you have to repeat it again and again, that's no problem. Just make slight changes, and for the rest, select all and press 1 enter. Everything is done. It's so fast and so powerful. Let's go ahead with the next thing. So next thing I will discuss is the difference between EFA and the CFA. Now we are in the second last session. I do understand I'm a little bit fast. Probably it's only for those people who have done it earlier, EFA, CFA, maybe they are able to connect, but others, you can just listen. In the EFA, look for primary thing. I'm telling maybe a little backside story. We are working on the OLS regression, ordinary least square regression. How it works? Basically, this is the file, just like the multiple regression. I ask my RStudio to give me the value of A11, A22, A13, and so on. Okay, Z-S1. So S1 statement I have converted into the Z score. I will multiply, add, it will become factor 2. For factor 1. For factor 2, this Z score will be same. I will just change the value. Remember to calculate the B1, B2, B3 values of regression coefficient, multiply with X, add up, plus some intercept term, and it becomes your YC computed value. Likewise, we compute here the score. But when we come to CFA, the concept is totally reverse way. In CFA, the concept is totally reverse way. Number one, we are not discussing MLE, this OLS method, ordinary least square. We are discussing here the MLE method, maximum likelihood estimation. What is meant by this? This is given by R.A. Fisher. R.A. Fisher said that, see, if these are 5-1 statement, 4 statements are there, if these are really reflective, so what we'll do, we will make a factor, and from the factor, we will predict the statement. So listen it again. What I am saying here that we will make a factor, and from the factor we will predict the S1. Okay, let's do it. Okay, then from the same factor we will predict the S2. From the same factor we will predict the S3, then the S4. Now please see here, we are totally reverse way we are talking. Actually, we got the value of S1 with us. I don't have a S1. So what I say, no, I will make a factor, and from the factor I will predict the value of S1. So one is the actual value I have from the respondent, and one is the which I predicted. Now, if I take the difference between the two, that's called residual. What's your point of view? Large residual is good or small residual is good? One is the actual value taken by the respondent. One I will predict using my factor. The difference is called as the residual. If the residual is 0, it means my prediction is at par with that of the actual value. Lower residual is preferred. But the problem here is the same F1 is expected to predict the S2 also, S3 also, S4 also. Can you see something? How can it predict S2 also? Only when these are closely connected, S1, S2, S3 are very closely connected. When they are reflective, F1 will be comfortably able to predict all of them. First, look how I'm speaking. I am saying factor is predicting S1. So who will be the dependent? Who will be the independent? Please remember that. So S1 will be dependent and F1 is the independent. So if I represent it on a diagram, the arrow will go from F1 to S1. Maybe I have not discussed it yesterday, but when we represent the diagram, model formation, etc., we use arrow. Where from arrow comes out, that's called exogenous variable, independent variable. EX in English means out. Endo, EN means inside. Where the head of the arrow will touch, that will be called as the dependent variable. So in this case, look what I'm speaking. I'm saying F1 will predict S1. So arrow will be inside S1. It will come out of the F1. F1 will be exogenous variable. S1 will be endogenous variable. But the same F1 is expected to predict the second also, third also, fourth also. Just think of, if they are very close connected, F1 will be very comfortably able to predict all of them. If they are formative scale, F1 will not be able to predict. They are different things. So it means if it is a reflective, we can comfortably go ahead with CFA and we can go for the reverse method. We will make a value of F1. Again, you can say how you will make. Okay, we'll start taking a random value. Then we will find out the value of A1 so that this is computed, and whatever is left out will go to the residual. But since F1 has to compute S2 also, now it will readjust the value of this A1 so that the A1 value to come so that the residuals are minimized. It will go again and again. So number one, how to know whether this method is correct or not? For that, Fisher said, well, for that I will use, my competitor Fisher has, Carl Pearson has given something, chi-square test. Remember, observed and expected, the difference between these. He said, we will go to that chi-square test. We will find out whether the chi-square value is okay or not, whether the difference is minimum or not. So you understand the meaning of model fit. Why model fit? Because from the factor we are predicting. Now, if we make this diagram, yesterday I told you something, if you remember those rules, and let me show you those rules once again. These are the rules. Okay. Not here. Which file? PLS rules. See, these were some of the rules I shared with you. I said that anything that is the latent variable will be put in the form of circle, and anything that is observed statement is box. Let me make it more clear today. Anything that's there in the file, your input file, maybe SPSS file, Excel file, that will always be the box. Anything. So look, I wanted to ask motivation of Yasha. I won't ask how much motivated you are, Yasha. I will ask certain statements or certain things. The things which I'll ask, the result of which Yasha replied in the numbers, I put it into my file, Excel file, SPSS or Stata file, that will be put into the box format. But where is motivation? Is there any column called motivation? If you say, yeah, I have taken the average of the 4, that will again, that is my motivation, that will again will be the box. If you say, no, motivation is to be inferred, that is not available in the file, that will be the circle. Please remember that this is the basic CFA rules for almost any software you work with. This is the basic building block. Even we define models using this. Anything that is intangible, that is not in the file, that is inferred, will be circle. Anything that is actually in the file, SPSS, Excel, Stata file, that is the box. Decide yourself. If you have taken average, if you have taken sum of a construct, it is very much in the file and you should define that with the box. If you say no, from it we will compute, that will be called as a box. Then we discussed reflective, formative and so on. So if you look for this, when from the circle, that is the factor construct, the statement is going towards the statement. This is called as the reflective model, and this is causal formative. When from the statement is going towards the factor. This is called causal formative, which Dr. Sandeep discussed yesterday. Side of the direction of the arrow is everything. Look, it's a very sorry. This is important. If from your factor, the statement is going towards the item statement, it is called as the reflective model. From the formative, now there may not be a correlation, but they are highly correlated. These are highly correlated. In the reflective model, multicollinearity is a good news, because multicollinearity here is called by several names. Its names are the same becomes Cronberg alpha, the same becomes the composite reliability. Multicollinearity is a good news in reflective because it means all are very, very closely connected. The multicollinearity in formative is really bad because this is nothing but a sort of multiple regression. The more related they are, they will kick out each other. Okay, so that's the problem. So there is one more term we call, it's called inner model and the outer model. So when there is a relationship between the constructs like A and B leads to C, this is called inner model, and this one is called as the outer model. Outer model calls about, yesterday I told you, whenever I will talk about the formative model, how will you recognize it's formative? From the statement, the arrow will be towards the circle, towards the construct. So those who have worked with the MOS, they know this thing is not possible in MOS. So that's why MOS works only on the reflective. MOS can handle this construct B, statement 10, 11, 12. It can work with the construct C, these statements, but it cannot work with the construct A because it is formative. Smart PLS, RStudio and others, they are very comfortable with formative and the reflective. No problem with that. A model or structural model. The relation of a construct with its statement, whether formative or reflective, it is called as the outer model or measurement model. When we talk of the formative model, please remember, I will use the term wait. I will not speak loading, I will say wait. When it is the reflective, I will coin the term loading. Though software will give you both, but we will, in terms of reflective, we will take only loadings. In terms of the formative, we will take wait. Okay. And here, this is nothing but the regression. So one other difference in MOS and smart PLS is MOS used to say that first you work on the measurement model and then you come to the structural model. First, maybe you should check individual construct with its statement, then all the construct, and then go for the structural model. Smart PLS says, no, just work with the construct model. I will automatically assume what if there is a measurement model. I will check rest of the things, but you make the structural model. You cannot make two circles and join it with a there is no two-sided arrow in smart PLS. So you join them only with the one-sided arrow. It works structural, and automatically in the process it will compute the all sort of your the models. So coming back here, which file we were working with, CFA. So here now we come across with this thing. There is this sort of a factor, and from the factor we are making the statement. Okay. Now these are certain rules. There are some error terms because it may not be explained fully. That part will go to the error term. Whatever is left out, that will go to the error term. So there can be any number of statement, and this one is called as the reflective. This one is called as the reflective construct. That's what the one thing, whatever the one will answer, other are just for the cross checking. So if I'll remove anyone, absolutely no problem. If I'll add one, no problem. Generally, MOS says there should be minimum 3 statement. That's for the technical reason, otherwise degree of freedom is negative. MOS says for a particular construct, minimum 3 statement you should take. MOS never works on a single statement. That's not a construct actually in that case, reflective construct. Smart PLS says I am very comfortable. I can work on the single item. I can work on the multiple, reflective, formative, everything. That's no problem to me. So now the question comes, now 2 things we come across. Number 1, first the question is how much F1 is able to predict S1. That's how much goodness. That's called model fit. What is meant by the model fit? Model fit means, remember, maximum likelihood estimation. Take the name. Maximum likelihood estimation. I will go for an estimation. Estimation for what? For the maximum likelihood estimation. Estimation where I will go for likely value. Whose likely value? Of the actual values are given, I will try to predict with the factor the values as closely as possible. How to check that? So what we'll do, original value minus expected value. I will do the difference of the 2, and that will be checked as the model fit. Chi-square will be used for that. Now, procedure was developed, everything started, they started using chi-square test, and very soon they found that the chi-square test they are using is actually, numerical value is okay, but significance value got a problem. Numerical value of chi-square is okay, but the significance value is always problematic. That's a biased estimator. So people were concerned, now what we should do, it's a biased estimator. So many people come out. We look at the indicators. These are called or some high value. So let me show you. This is what we report. Hope it's visible to you on the one page. So while reporting CFA result, there are the basically 3 things we look for. Basically are 2. One is simply the p-value, regression result. Remember, p-value should be less than 0.5. That's a thumb rule that must be there. Now, 2 are the main issue. One is the validity issues. One is the model fit indicator. First, let's talk of the validity issue. In the validity issue, there is a content validity. And I spoke yesterday also, there are no numerical formulas for the content validity. For the content validity, all you need to do is through review of literature, expert opinion. So you refer all sort of the possible things that I have consulted all high-end journals, highly cited papers on that area which the software publisher Parish will give you, or you can go for the Google Scholar, talk to the ResearchGate, academy.edu, highly cited papers you should refer. Just give me a minute, 1 minute, please. Okay. So go for the review of literature, go for the expert opinion, talk to the people, experts of that area, and they will confirm whether the content you miss anything or the constructs are okay and adequate coverage is there. Second part is the construct validity. That consists of two parts, whether the construct is good or not. Remember, the construct is the backbone of your research. If the construct is okay, things are okay. If the construct is wrong, then there are very, less contribution of your research. One is the convergent validity, and here are the three formulas. What are the three formulas? CR greater than 0.7. CR here stands for composite reliability. It is not Cronbach alpha. It is not critical ratio. Critical ratio is Z test. I must call it a CR critical ratio, but this is composite reliability. There is a formula for the same. Then there is a AVE, average variance explained, or some people call it extracted. It should be more than 50%. And third is CR must be greater than AVE, average variance explained. Likewise, there is something called discriminant validity, AVE greater than MSV. The meaning of MSV is maximum shared variance, and ASV is the average shared variance. The same AVE, which is here, will be here also. So if you look for, in total, we got 3-4 things. One is CR, one is AVE, and the third is MSV. People actually don't use this one. Earlier people used to work, because now they find that whenever it's greater than MSV, it has to be greater than ASV. So actually you can remove this, you can skip this. It is redundant sort of. I will show you how to calculate that their values. Going ahead, the next part comes here as the second part comes here, that what is the value of the model fitness. Look for the model fitness indicators. In the model fitness indicator, we will find there is something called the 1 chi-square value that you need to report. Its significance value is biased, but numerical value is still reported. Numerical value you must be reported. That's where we discussed, if a C mean YDF value is less than 3, almost all the indicators will be good. If they are more than 5, almost all the indicators will be bad. Rest all the indicators are actually computed from this value, most of them. I have explained in one video the manual calculations of CFI, GFI, what are the formula, how to calculate manually. I have explained it in one video, but we will work with the software here. So in the model fit indicators, one called goodness of fit, it's the CFI, comparative fit indicator, GFI, goodness of fit indicator, incremental fit indicator, NEO. So there are these so many indicators. AGFI, it's adjusted goodness of fit indicator. There is something called badness of it, RMSC, etc. Well, I recently got so much scolded from one of my mentor. He said, there is nothing called the badness of it. This is your own term. All are goodness of fit indicator. RMSC value, lower value are preferred. Here, the higher value are preferred. There is no such term called badness of it. Well, we generally call it, but meaning of the badness is the lower values is better. So let's consider all as the goodness of fit indicator. Here the higher value is good. Here the lower value is good. The value always lies between 0 to 1 for maximum of them. Not all, for maximum of them. So when it comes to how high, so actually we'll prefer a highest value of 1. If it is 1, then it's a perfect the C mean value will be 0. When this chi-square value is 0, it means perfect prediction we have done. So all goodness of fit indicator will be 1. All these indicators will be 0. RMSE, root mean square error approximation, or RMR or standardized RMR. These are the other values. So generally, if they are not 1, our point is they should be very high. Something like more than 0.95 is really, we will happy with that. And the lower limit we have kept is as 0.9. So if these values are 0.9, CFI, GFI, IFI, etc., then it's okay. More than 0.95, it's really good. Likewise, for these indicators, less than 5%, it's really good, but up to 10% tolerable. We'll say it's okay. So now the thing is, in most of the papers, you will find any 3 values, like 1 is compulsory and any values are given. Chi-square value is compulsory. You must report it. You can report any of the value of a CFI, GFI, NFI. You can report any of them. That's okay. And you can report RMSC or this. Most of the paper, like it's a custom, people refer CFI and RMSC, but you can refer others also. That's absolutely no problem. There are so many other indicators also, TLI, and those are Tuckey-Lewis indicator and so on. standardized RMR, etc. So there is a chi-square. So we don't go for the value of the chi-square. Chi-square divided by degree of freedom. That value should be less than 3. If that value is less than 3, then generally these all indicators are pretty good. If that value is more than 5, generally these are not good. Generally, I'm not saying as a rule, but generally not good. So now when we are going, next time we are working with the CFA, whatever software you come across, these are the 3 things we remember. What are the 3 things? The first thing is the factor must explain. Remember, it's a sort of a regression. And if you look it once again, since you have not attended my workshop on regression, I always say, look at the arrow. Arrow decides what sort of regression is it. Can you tell how many independent variable are there in this one? How to decide dependent, independent? Head of the arrow means dependent and tail arrow is independent. So please see, it's not a case of multiple regression. Multiple regression is dependent 1, independent many. It's a very strange case. Here dependent are 4, independent is 1. So this is 4 simple regression. What's a simple regression? 1 dependent, 1 independent is called a simple regression. So in the picture, we have the 4 simple regression. Now in the simple regression, there is a magic word is there. R is equal to beta. Small r, which is relation between x and y, is equal to capital R, which is relation between y and yc, is equal to beta, which is a relation between zx and zy. So here the beta and r are the one and the same thing. So that's why here we take regression 1, then validity, we will take beta in all of them, convergent, discriminant, we will take beta. And then the third one is the model fit. These 3 things we report. Dr. Sandeep also shared the same. Later he added something more, like in discriminant validity, other than these 2, you may add STMT also. Yes. Then people said in this CR, other than CR, you may add some Jokersburg or other criteria. There is a row that is also there. So many people with the so many new indicators are coming up for every, which can be computed only in their software, nowhere else. So yes, there are so many criteria. These are the base criteria. Then there is a row A, row C. Likewise here, STMT is there, and people are every day coming with the new indicators. But these are the fundamental one. Now our question is how to represent it. There is something called the orders of CFA. Again, Frahat once told me that, there is no such term called zero order. This is your own term. Okay, I accept it. You may not find zero order somewhere, but the meaning of the zero order is a construct with its statement. I call them as zero order. Okay. Then when there are the 2 constructs and they are very highly correlated, so we say service quality please see, remember what is a construct? It is intangible. A construct is intangible, it's not there, which we will infer. So we will infer tangibility from these 4 statements, we will infer empathy from these 4 statements, and we will infer service quality with the taken 2, both of them taken together. So when a construct is made up of another construct, it is called second order. So this is a second order we make again, it's called reflective. This is also reflective, this is also reflective. Again, there are 4 sort of a higher order construct. This is called higher order, second order, third order. They are called higher order. HOC, higher order construct. There are the 4. What are the 4? This is an example of reflective. It can be reflective formative, like this is a reflective, this is reflective, and together they constitute this. Arrow will be on this side. Reflective, formative. It can be formative, reflective. This is a formative, this is formative, but they are reflective, or formative. 4 options are available here. So that's in the smart PLS you can handle them. But problem with the MOS is you can work on the only second order reflective. Formative, there is no space for formative here. Now this is an example of third order. Why it is a third order? This construct is made up of statement. This is made up of this statement. Taken together, they make service quality. Service quality and technical quality make the overall quality. Look at the overall quality. So this is 1, this is second, and this is the third. Okay, but please look for, I'm not using the term first order. I'm not calling it as the first order. I said it zero order. Okay, this one I am calling it as zero order. I am not calling it as the first order. First order is a special name to something. Whenever we are looking for discriminant validity, then the term second order is there. You know, life is so complex and this terminology has made even more complex. There is a zero order, there is a second order, third order, fourth order. First order doesn't fall in this line. There is nothing first order. So what is the first order? When we are checking whether the two constructs are different or not, discriminant validity. So see it, it's a first order. What is a first order? Tangibility is made up of this one. Then empathy is made up of this much. Service quality is made up of both of them taken together, this much. And then satisfaction is made up of this. I call satisfaction as the zero order. And then when you check the relation between these two, this is first order. So please look, in AMOS, we represent it by a two-sided arrow. Two-sided arrow means we say this is a correlation or covariance. Correlation and covariance are simply standardized and unstandardized, nothing more than that. So what is the first order? You please understand it this way. Whenever you are querying, say I'm discriminant validity. Discriminant means different for what? For R. What is their relationship? That is called as the discriminant validity or first order. So if you are not getting anything, no problem. Just note it down. Convergent validity means a construct with its statement. I call them as zero order. If your construct is made up of other construct, it's second order. Then if the made up of further constructs, it's third order. But where is the zero? First order. First order means when you are checking a two-sided arrow between the two construct, that is called as the first order. The meaning of the first order is check whether the two are related or not, discriminant validity. And for rest all, there is a convergent validity. Please remember that thing. It means if you are working on the second order, like the case of this, then you must report the convergent validity of this tangibility, convergent validity of empathy, as well as convergent validity of the service quality, taking from this both of them. Okay, all we require is a beta, and from beta we can compute the rest of the things. So what we require is, we don't require too many things. Let me show you how to do it in AMOS. This is a diagram in AMOS. Again, if you have worked in AMOS, then it's a fantastic. If you have never worked in AMOS, then just see that it's something like this. In that, I said that quality is made up of 6 statements, 1, 2, 3, 4, 5, 6. Behavioral intention is made up of 6. Satisfaction made of 4. This is made up of 4. When you make any like this, from this arrow is going from this side, why there is a circle? Because the satisfaction is not anywhere in the file, SPSS file or the Excel file. This one, set one, items are there, statements are there in the SPSS file, not this. Remember, circle means it's intangible. It's not in the file. Constructs, which we will infer. And box means this is very much in the file. It is observed variable. Second point, where the arrow will be. Technically in the MLE method, this is independent and this is a dependent variable. Looking perspective, one dependent, one independent. This is a simple regression. This arrow is a simple regression. In the simple regression, R is equal to beta. So it will give, AMOS will give me the beta. I will understand that beta is nothing but R. Okay. So these things you need to know. Going ahead, I attach the file and let me run it in AMOS. So AMOS gives me output. It will turn red. Okay. And these values will come. What are these values? So it is telling me that when I run the beta value from quality to is this one is 0.88. Beta is ZX and the ZY. The value of ZX and ZY is called as the beta. So the same is called as the R. Beta is R. I will call quality and quality 1. Their relation is 0.88. This is R. This is R, small r, coefficient correlation. Second is 0.75. So what is R square if we take? So we can compute the R square from here. Squared multiple correlation and compute it once again. We are looking for whether quality is able to predict it properly or not. What is meant by properly? Let's see here. Quality is able to 70% of the variations of quality 1, 77 variations, 77%. Where are the rest of the 23? They will go to the residual. The second, it's 0.56, 56% it is able to do. The rest goes to error. I hope it will be a little bit more helpful. Quality 3, it is able to explain. So if you do simply 0.85 into 0.85, it will come 73. This is R and this is R square. Simple, square of R is R square. 80, it becomes 70, 71 becomes 50. So now, is there any indicator how much should be, like what is the minimum R square we should expect? So we say not for the, some people say every statement should be minimum 50%. Some other people say there can be something can be small, something can be loss. On an average 77, 56, this must be 50%. Please look for, if you are coming from regression, then you understand this is R square. Other name of R square is variance explained. What is R square? Variance explained. So I am saying average variance explained should be 50%. It means this one 77 plus 56, 73, 70, 50, 41. This average should be 50%. This is what I'm saying. Now for that, I have given you Excel file. In this Excel file, I have written the formula of reliability and AVE is written, standardized loading. What we need to do, we will just put these values. See, 0.88. So it comes to 77. Can you see this 77? 75, 0.75. Next one is 85, 84. The next one comes 71, 64. 71 and 64. So our AVE value comes to be 0.613. What is the rule? It must be greater than 0.5. Hope Dr. Gautam got the answer. He asked yesterday that what need to be reported. We need to report these AVE and CR. What are the three rules? Look for the three rules. Rule number 1, AVE greater than 0.5, check, correct. CR, composite reliability. This is the formula given. Sum of loading square, this. Must be greater than 0.7, check, correct. Third, AVE must be, CR must be greater than AVE. Check this. All three are correct. Convergent validity hold true. See it once again. Convergent validity simply means a construct with its own statement. Do you remember that? Just give me a minute. I think it was the CFA concept that I have opened. I forget where this file was. Basically, I was saying that in this one, when you start with the CFA, there is a construct. In the construct, there are two sort of validity, convergent and discriminant. It means for quality, there will be a convergent validity. This is a construct. You will compute for the behavioral intention. You will compute for satisfaction. You will compute for loyalty. Okay. So just put the values 7970 in this Excel file and you will get the value of AVCR. And what are the rules? Rules are CR greater than 0.7. Second, AVE greater than 0.5. Third, CR greater than AVE. These are the three rules available. How to check the discriminant validity? So are you through with the AVE? For the quality, AVE comes 0.61. Now look for it. MSV, maximum shared variance, that is R between this. You must click on the, in AMOS, if you are working with AMOS, you must click on the standardized estimate, then it's the value of correlation. If you click on standardize, see these values are more than 1, etc. This is covariance. We work always with the standardized value called beta. My point here is quality is related with, there are three arrows, 1, 2, 3. Three arrows, can you see the three arrows here? Let me make a little bit more. Hope you are able to see quality, three arrows are there. Out of the three arrow, which arrow contains the maximum value? Out of the three, which arrow contains the maximum value? 0.67. Square of it will be called as maximum shared variance. Please remember, you will really understand statistics if you understand R. There is nothing other than R in the entire statistics. What is this? This is again R. What is its square? It's called R square. Okay, variance explained. Now out of the three, whosoever got the highest maximum, well, this seems to be a maximum. So its square will be called as MSV. How to find it out? For example, for the behavioral intention, how many arrows are there? 3 arrows. Out of the 3 arrow, tell me what are the values on each arrow? 0.57, 0.34, and third comes at 0.51, 1, 2, 3. Okay, which one is maximum? This one. It's a square, 0.57 into 0.57. How much it comes up? 0.3249, that is the MSV. Check what is the MSV for satisfaction. 3 arrows. One is 0.34, other is 0.6, and the third one comes 0.51. Which one is maximum? 0.69. So 0.69, then you again go for the maximum square of that. That will be MSV for satisfaction. Okay. For this, Professor Gaskin has given a plugin. Maximum people use that plugin. And if you are using some new versions, the plugin is available here also, master validity. You can click here itself. It works most of the time. It works only once. Then you need to restart and then it works. But when you work with this plugin, Professor Gaskin has given, and then directly you will get the Internet Explorer page. And on that, you will get all sort of the values computed. So it says, wow, no validity concern. These are the CRE value. These are MSV value. You can compute it manually also, but AVE, this. Problem with this is this works earlier versions. They worked only with the zero order. Okay, not with the second order. That's why I made this one file. Now this file is available with my video. I have given in that folder also. So you can compute AVE and the CR. Dr. Sandeep has also made a similar file where you can compute STMT, AVE, etc. I think I have also explained in the second sheet STMT and those sort of stuff. There is a video manual calculation of STMT. There I have explained these things. So it means if I have this file, Excel file with me, all I require is beta values. Convergent validity will come. For discriminant validity, I need to know the relation between these and which one is highest. I will check that. And then rest of the things I can compute for my own. What about the model fit? Model fit is given here. You come to the Amos output. Here you will find a complete detail. That's a model fit. All sort of the criteria are given here. Now Amos is pretty good with providing you some sort of limits also. You know, minimum and the maximum for every indicator. Like these days, when you go to any pathological lab, you conduct your urea test or blood sugar test, etc. You may not know what should be value, but there is a minimum maximum. If your falls in between, you are happy. Yeah, that's good. I'm okay. So here it's a model fit. Now C mean value comes out as 364. Degree of freedom is 183. So it comes 1.99. Less than 3, good. Look at the CFI value. It's 0.854. It's slightly less. Now for improving it, we have something called the modification indices. GFI value is very, very low, 0.74. NFI 0.75, not very good. 857, not very good. And RMSC value is 0.1, something tolerable. Should have been less. For improving these in Amos, we have something called the modifications. We can improve. I have explained this process in the playlist of Amos. Now, please look how we have done it. First, we made a diagram. Quality leads to this, this lead to this, and then we connected the arrow. Okay. Now we go for RStudio. And in the RStudio, please remember how we'll make the diagram. Please see this one. This is the way I will make my diagram in RStudio. It's really fun. If there is something called a regression, a tilde symbol. The name of this is TILDE, tilde. It's available on the keyboard. If those you are working on the laptop, look at your 1, 2, 3, 4 keys. Immediately left hand side of 1, you can see on the top its wave symbol is there. So shift and that symbol will generate this tilde. The meaning of the tilde is it's a regression. So whenever we use arguments, when we make a tilde symbol in between them, it means on the left hand side is the dependent variable, right hand side is the independent variable. When you make tilde 2 times, it becomes a correlation. So it's almost the same. as is the way of this AMOS. In the AMOS also we say that two-sided is correlation and one-sided is the regression. Likewise, the developers of this said that one tilde means regression and two tilde means correlation. Then if you need to define construct, please write equal to tilde. So equal to tilde means it is a construct. We are going to have fun by making the construct. It's so simple. Making equal to tilde will be the construct, and less than symbol and tilde, it will be composite. Now see, all EFA, CFA, CCA, all done in the 3-1. EFA, it's more of a tilde because it's a multiple regression. Remember, EFA, it's a multiple regression. CFA equal to tilde we will use, and in CCA less than tilde, this will become CCA. If you use this, it will become composite, this will become construct, and this will become simple regression. Let's see how we'll do that. I will show you how to do it in RStudio. So here the package I have used is, this is the same demo file. Let me use that demo file. I have that. The second is I have taken JED demo out of it, only from 10 to 30. I have taken first 9 columns I have dropped. Now this is my diagram. Just see and tell me, is it a beautiful diagram? How I write? I said, look at the AMOS. How I was working with AMOS? Quality, one-sided arrow are there. Quality got connected with 6. How I write here? Quality equal to tilde means it's a construct. Quality 1, quality 2. What is this? What are the names you are given in the file as such? Like look at the name, quality 1. If you are given Q1, Q2, write that. If you are given S1, S2, write that. I have given quality 1, quality 2, write their names, etc. That's it. No comma, nothing. First construct is over. So writing this line is equivalent to making this complete one. Making this particular thing. This is almost as if I have written this. Then satisfaction, this 4, loyalty, this 5, behavioral intention, this 6. It means I have done all sort of these circles. Okay. Now the second part. What about connecting these two? Any guess? How will you connect this? For connection, we had something called tilde tilde. So I will write quality tilde tilde satisfaction. It's equivalent to making a two-sided arrow between the two. So let me write for all. Quality and behavioral intention, quality loyalty, satisfaction behavioral, satisfaction loyalty, behavioral intention loyalty. And all remember apostrophe s, apostrophe. So all pair of apostrophe, it means this complete becomes this diagram. It's equivalent to this diagram. You have made such a big diagram. I have written 5-6 lines. Now it's so simple here. Next time if somebody will say, please delete quality 3. Okay, delete, done. That's as simple as that. So if you want to add anyone, add here. The things are so simple. You can write as many constructs. In the AMOS, etc., people will say, you know, canvas is small, there is so much congested. No problem here. So one, I have first library, Lavan. Lavan, what is Lavan? LA, latent, VA, variable, AN, analysis. Latent variable analysis. This is the library I called. This is library for this sort of CFA. What was the library for EFA? Psyche, PSYCH, Lavan. In the Lavan, first thing is make a diagram, just equivalent to you make in the AMOS, make the diagram. Okay. Then second thing, there is a command CFA. Only 2 arguments are required. First, the diagram. This is your diagram. And second is the data file. Here also, if you make the diagram and you run, it won't run until unless you attach a data file. Remember A9, attach a data file. When you attach a data file only, so you make a diagram and attach the data file, 2 are the things required. The same 2 are required here. X means this is my diagram and data is equal to Z. Why Z? Why not demo? Because the demo contains age, income, gender, those things also. Hindi, English, marks, etc. I want only that are on the scale, 5-point scale. So I have extracted from the demo. You could have done that. Don't take it in the Excel or SPSS file. Then you can simply write a demo. But if it's there using capital bracket, I have removed the first 9 column. What is meant by this blank? If you don't write anything, all the rows. First row, then the column. If you don't write like this, what it will become? all the row and all the columns, entire demo will come. But we are using bracket, it means we want only column number 10 to 3. Space doesn't matter. If you write this way, this will be the same. Space doesn't matter. Space independent, but in case you write capital D, now it will be error, because it will say, what is this capital D? I don't recognize, because your answer, you already said it's a small d emo. Please remember, it's a case sensitive language. Z done, head I don't require, library done, X, this I've done. Now let me run I am saving the output of CFA in XX. Done. Everything is done. CFA is complete. So let me show you the results now. Where are the results of this? Okay, let me show you the results. So I think I have, shall I make it like this? The results will come here. Now, what sort of results we require? We require a model fit. We require beta value. We require parameter estimate. We require modification indices. You just name it. Everything comes in the XX. So see, I'm doing here summary XX standardized equal to true. Standardized true means also give me the standardized result. Look in the AMOS. When you say run it, okay, run. Then when you say show the result, okay, show. And then you say only standardize, show me only standardize. Like here is, I am saying here that run it, this is all run. Summary, XX, what is XX? This value, entire output. And standardized to also show me the standard result. See, the moment I will press this, you will get a flood of output. This much output is there. So let me run it once again so that it comes into one screen. Oh, summary of this. I have zoomed it to a great extent. Maybe this will help. Give me a minute. Maybe it's my zoom is so much, that's why you are not able to see completely. Let's see. It says now Lavan 0.6, so 40 iteration it ended. Estimator is maximum likelihood estimator. Optimized method is this. Number of free parameter observation is 100. Sample size. Test statistics is 368. 183 is the degree of freedom. You can compare. It's the exactly same with the AMOS. These are the values. Where can we see these values in AMOS? If you look in the AMOS, in the output, the first one is here. It's called as the estimate. Remember this? These are the parameter estimate. Where you put the value of 1, that is CR not calculated. What is CR? Z-test. And p-value less than 0.05 is kept as triple star. So all these values, if you require, but we don't require it at any time, but if you require it, it's available here in R like these values. Where you put 1, this is not given, rest all are given. Remember, these are unstandardized estimate. It can be more than 1. Don't worry about it. We have to look at this last column. 0.878, 746, 752, etc. Shall I check it? Was it the same? The first one is 878. So AMOS is programmed to give output up to 2 decimal place. So 878 becomes 88. 746 becomes 75. 852 becomes 85, and so on. So do you get this? For the quality, you get this standardized estimate. For this satisfaction, you got this one. For loyalty, these are the things. Behavioral intention, these are the things. You can cross check. Covariance, what is the relation between this? Let's see. Quality and satisfaction, what is their relation? Quality and satisfaction, it is 0.43. This one. So what is our quality and satisfaction comes? Look at the last one, 0.43. It is the same one. Quality and behavioral intention, point this. So if I have to take MSV for quality, how I will do? Find out who's the maximum in the 3. Find out who's the maximum in the 3 and take its square. That will be called MSV. And what was our formula? AVE should be greater than MSV. AVE should be greater than MSV. Now there was a second thing also. What about ASV? If you take average of these 3, 433, 573, 666, and take its square, it will be ASV, average squared variations. Now later on, people realize that when some value is greater than this, whenever you take any average, the ASV will always be less. MSV value will always and always be greater than MSV. And when something is greater than MSV, do you need to check whether it's greater than ASV? It will always be greater. Need not to check. So people report these days only MSV, don't report ASV. Likewise this, then variances, etc. These are done with you. Next, what you require fit measures. You know those, how many measures we have here? I can assure you, R will give something, just calculate all, RMR, GFI, AGFA, NFI, CFI, this one, NCP, so many are there, don't worry. Click on the fit measures XX, done, and these are all indicators are available. This is NPAR, NFIN, chi-square by DF, p-value, TLI, NNFI, RFI, whatever you can think of, all indicators are here. All, RMSE, upper, lower, mean, median, SMR, everything is given here. MFA, just choose and report the relevant one. If you want standardized solution, so there is a complete function standardized solution, write XX. So let's see, it should give you the complete solution. This one is the complete solution. Here it takes this standardized value, standard estimate, Z value, P value, lower limit, upper limit, if you want it anytime, though we don't require it, but if you want it, it's available here. Next is the modification indices. I remember there were modification indices. So my formula for modification indices is mode indices XX and minimum value is equal to, I have given a cutoff, minimum value is 10. Let's run it MI and print it. It says if you connect satisfaction with behavioral intention, discrepancy will go down by 10. So what is the rule? The rule is you can make a two-sided arrow in this diagram. Modification indices say error terms of a construct can be related, like this can be related, this can be related, okay, but there is no way this can be related to it. Generally not accepted, generally not accepted. So I have made a separate video about the modification indices, when to use, when not to use, what is the rationale behind it. That's most important, how to report it. So here I assume I can't teach all that one. So, but that's videos are available. You can work for that. So just check it here. Where are the error terms like loyalty 2 and loyalty 3? If you add a two-sided arrow, so this is fun. How to add? Just copy from here, okay, and write in your model. What was your diagram? This was the diagram. Done. So it's something like I have added. Remember what is tilde? It's a two-sided arrow. So I have attached loyalty 2 and loyalty 3. Obviously, I will run it once again. Loyalty behavioral intention cannot be, doesn't make sense. Quality 6, quality 5. Variation will go down by, discrepancy will go down by 10.8. Let's copy it. Let's use that also. So this is my diagram in the green color. Anything else? Behavioral intention loyalty, no. Behavioral loyalty, no. Satisfaction, no. Only 2 I can do. That is actually more than 10, it will improve. So look at do I have that value of, so that I will cross check fit measures. Yeah. Look at my chi-square value. Chi-square value is 368. So basically 10 units will go down by this loyalty 3, 10 units will go down. I expect it to something like 348 or something next time. So let's run it once again. So run the CFA and fit measures. So, oh, some error, missed value, or is there some issue it's saying. Quality 611, what happened? Something mistake I have committed? Oh, I have written this 10.89 also, need not to be, only correct syntax, quality 6. Run, this run, and fit measures run. Look at the value of chi-square 346. Yeah, almost more than 20. From 368, it went for that. This is what was expected. It will go down. So what is the purpose of modification indices? For improving the model fit. We use this. So what else is there? If you want the score, remember in the MOs, there is a point of impute. So we say here, analyze data imputation. Meaning of imputation is you save the score of this construct into the SPSS file. The same we can do with the help of lav predict. There is a function lav predict. I say the score of this, let me save in the XXX. From the XXX, okay. For some reason, When you import a SPSS file, this lev predict doesn't work. That's why for this particular reason, I have I have not given you the SPSS file. I have given you CSV file. So if you allow me, I will show you. Let me remove all. Okay, I'm working from the start and see how much time it should take me. From CSV, where is the folder? It's a demo, this file. Step number 1, import. Its name will be demo. Okay. View is the part of that import. Okay. Now it says attach demo. Yeah. Make the jet. When it says masking, it means you already opened a file. There also these were the same names. Now new file also the same name. Don't worry. This is simply warning. JED I extracted. First I imported. Second I attached. Third step made the demo. Fourth step, once you call a package, it's already available. It's always available until unless you close the RStudio. If you close the RStudio, then you need to run it again. Otherwise, it's already there. How to cross check it? See in the package, if you write the Lavan, L-A-V-A-A-N, so there is a tick mark. It means it's already called in the session. It's available. Need not to run it again. X run. X run, and this is the, let me go for the summary with a little bit. I'm doing every time because I want to show you, otherwise that's why I have zoomed in, that's why I'm doing it, summary. And this is the entire result here available. So you can see how many things I have done. 4 step, imported, attached, then maybe if there is something else, remove those extra part, age, income, gender, etc. Make a diagram and run. 5 step and entire the things are done. It's at par. You know, by the time you will make your circles and the boxes in the MS, this will already reach in the MS Word file. These are the things which you require. Again, use that Excel file for computing your AVE and the CR. Maybe you need to calculate it manually for the MSV, etc. MSV you will take from here. 0.4 for which one is the largest, take the square. That's MSV for quality. For satisfaction, likewise, etc. Variance we don't require. Fit measures. So this is the fit measure. All fit measures are available. Standard solution. This is the complete standardized solution. Modification indices. This is the modification indices. Lev predict with the CSV file, lev predict will work. With the SPSS file where you have given the label, it doesn't work for some strange reasons. Quality 1, loyalty, behavioral intention, and let me check their correlation. This is the correlation matrix. Quality with satisfaction 0.8. Well, that's already available with us. But this is for the score computed. Remember, this is the score computed from the MLE method. So it's not exactly same if you do it in EFA and then check it. That's OLS method. And by the way, their correlation will be 0. Remember, number 1, the factor is not about the quality. It contains all of them. Quality is a major one. And then it's made in such a way that their score will be 0. So here the score, their R is 0. Here the R is there, 0.487, 806, etc. We have some R. So this was about, okay, what about that diagram? People say, no, that's okay, but can't I make a diagram? Yeah, you can make, but not so beautifully. Remember, you are working on the free software. So there is something called Samplot. There is another package you need to call Samplot. Done. And the output of the XX, put it into the Samplot. Now, before that, let me create some space. Where my output will come? In the plots. It will come here in the plots. So let's see it here. It may not be that beautiful. Okay. Sampath. So this red means it's working. It's running. Making the diagram. What I've said, layout tree 2. There are many layouts available. I will show you what standardized should be shown. It says it's written by very huge number. Don't worry. Sample author it will come. Next it said edge color is 1, that's black color. Rotation 4 means this on this side. This is on this side. CEX means character expansion, make it a little small. If you want to see it in detail, you can zoom and it's available here. Okay, this is quality. Well, I understand it's not that beautiful. This is satisfaction, loyalty, behavioral intention. They are connected. This is MSV and these are those values. We can do just a little here and there instead of edge color 1. Do you like the red color? 2 is the red color here. Edge color 2 means the red color. So now it will turn red. Okay. Edge color 4 means green perhaps. So it will turn to the green color, blue color. 3 is the green. Rotation. If you want a rotation as 1, so it will be something like this way. Okay. If you do rotation as the 2, it will be maybe this way. CEX is how much bigger or the smaller. If I'll say 5, it will be, I think, much bigger. Oh, it's a simple, smaller perhaps, I think. These are a little bit increased. So instead of a tree 2, what if, how do you remember that what is the layout? Well, tell you the truth, even I don't remember. And there is no need. We will write question mark, SAM, it's a SAM path, yeah. SAM path. Tell me the various arguments of the SAM path. What can I see there? What are the things available? Automatically, it will go to the help. It will say, oh my God, can you believe it? These much arguments are there. No software gives you this much functionality. You can do every single thing, curve, curvature, number of characters, node, size. You can do every single thing. None of the software gives you this much functionality. So in the what I can show on the diagram, standardized value, equation value, colors, path values, parameters I can show, what label, this I can show, style, layout, tree, circle, spring, tree 2. Shall we make certain just fun? Let's see what is the tree. It's just on the fun side. Okay. So it will automatically come to plot. This is tree. I don't see what's the difference between these two. Circle. Circle, it say, then it says rotation may be a problem with the circle. Okay, I don't want rotation in the circle. Will it work? Wow, have you ever seen diagram like this? I remember those earlier versions of before PLS, there was something called PLS graph. PLS graph used to make this this sort of diagram, that there was a construct and all in the circle, etc. So you can just try the other things. Question mark, SAM path, it will give you the detail of what are the things available. Okay, so basic thing is, this is a drawing painting part aside. Basic thing, what we require, we need to plot what? One, the model fit indicators. That you have all the model fit indicators available here. This is called as the fit measures, and all these measures will come. How I set this console on this side, left side, right side? If you want a graph, then generally console should be put on the left side. The option is view, pane, console on the left. So when you require diagram, something, then you know it requires little bit space. Console, send console on the left side. If you don't require diagram, then console on the right side, and minimize this and minimize this also. Now it becomes left side I will write my input, right side I will get the output. So this is my all model fit indicators. If you want standardized solution, this is all the standardized solution. Just look at the last column. This value, estimate standardized. These are the beta values used for the computation of AVE, MSV, CR. Obviously, you will use this file. Everybody use this file given by Professor Gaskin, or you can use my file. And that's it. This is all about CFA. Measurement model. Now, structural model means that's a pure regression. So just see, I have calculated here the value of quality, satisfaction, loyalty. Shall I run the regression? So regression will be simply satisfaction depends on quality. Oh, sorry, LM, I should write LM. LM is the term for linear model. Let me zoom it a little bit so that you can see. LM, satis. So just first see the names I have taken lev predict. From the lev predict, I have predicted the first variable as quality, satis with second, loyal third, BEHS the fourth. I am writing it as LM means a linear model, run a linear model. Satis depends on quality. That's it. Let's try to run this. And for that, we need to see the summary also. If you were there in the last session, you know what I'm doing, else it will be a little tricky for you. So it comes to the regression output, residual, minimum, maximum, coefficient. This is the intercept value. This is the quality value. T value is good. There is a significant effect of quality on the satisfaction. Likewise, if you want to go for quality plus loyalty, so plus LOY, loyal. Now this becomes a case of multiple regression. There's an effect of quality, there's an effect of loyalty. It may be not very beautiful because I have done excess zoom. That's why it's not visible to you. Hop this way, now it's okay, little bit. It's because of zoom, nothing, no problem with the R. So this is the same table as SPSS gives, table number 3. Quality has insignificant, P value is less or T value is greater than 2. Loyalty, T value greater than 2, value is less than this. R square is 70%, which is very, very high. Adjusted R square is 69. F statistics says model is good. All the things. Not into that format, but it's available. And there are something like, if you want SPSS like format, then J tools is the package. You should use that and it will be very beautiful. So this is a measurement model and the structural model. I thought it will take a lot of time, but I am able to cover it 15 minutes prior to that. Yeah, are you there? Are you still listening to me? Okay. So see, initially you need to develop a flavor of R. First thing, do have to type a lot, little bit, as much as you want to type in Excel. You know, in Excel also you need to type. For your kind information, Excel doesn't read your mind. Excel also asks you to type, but at least 3 alphabets. Then there is a drop menu and then press the tab, the things will come. What are the things here? No, those bulky diagrams, things, etc. These are very small, right? There is a model equal to tilde. So you need to remember, if you write simple tilde, it becomes regression. Equal to tilde, it becomes the construct. And less than tilde, it becomes the composite. So such a simple thing here. Then the second thing is simply run a command CFA. Entire output will come here and then take anything out of it. Fit measures are there, modification indices, whatever you can think of.